Here we've got one of the core sections which has been drilled on the Lomonosov Ridge during the Arctic coring expedition.
This is a true treasure of the deep, worth its weight in gold. A time capsule that holds secrets from the past, vital to the future. Its story is a story of skill, dedication, and scientific excellence, and of voyages of discovery to some of the most demanding places in the world.
Fantastic experience.
Very complex.
An astonishing achievement.
Very draining.
The voyage of discovery.
Some of the best scientists in the world.
It's an international family.
An enormous team effort.
That's what it's all about.
If we want to really understand what we are doing to our planet,
We need answers
we need to understand how it worked in the past.
to urgent questions.
A car park at Bremen University in Germany.
This is the container I actually spent about 5 weeks in. Yeah, 5 weeks, 3 to 5 persons, sometimes at one time. I really like it. I like to work in these kind of environments.
For geochemist Lutz Schneider, this cramped space is a reminder of one of the very best times of her professional life. An expedition to a part of the world most of us will never see. In 2004, a voyage into unknown waters for Lutzi and for geology in the Arctic Ocean.
Very crowded, very loud and very cold, of course.
The mission to drill down into the seabed below the Arctic ice and bring back a series of cores for geoscientists all over the world to analyse. The first time anyone had ever attempted Arctic seabed drilling on this scale, and one of the most technically demanding seabed drilling projects ever undertaken.
The main problem up there was coping with the ice flows, and the ice tended to push the drill vessel off position.
You really have to break these big ice floes apart in order to make it possible for the drill ship to keep station.
Take one of these ice-breaking vessels and punch a hole through the middle of it. Build a drilling rig on top of that.
With 2 other icebreakers, and these 2 vessels together worked to clear the ice so that the drill ship could remain on station.
It was a completely new concept of how to do this.
In the end, we came back with over 600 metres of core. One of the most exciting findings was that the Arctic used to be ice-free, very high sea surface temperatures, up to 24 degrees.
All the seaways were closed, and that means that we nearly had freshwater conditions. Normally, it's hard to find those places from a totally different environment through the process of changing into an environment you find today.
History that's stored within those cores, it is the only record that goes back that period of time, back to 55 million years. So yes, the cores are extremely valuable.
It worked out extremely well.
I think that the expedition was a tremendous scientific success.
A success and a great start for a new name. ECORD was born in 2003. A scientific consortium of 16 European countries and Canada formed to support the work of the global IODP project.
IODP contributes to the understanding of how the Earth functions, and IODP does it by providing data collected from the subsea floor using drill ships and drilling platforms.
ECORD's contribution to bridge a gap in the work of the IODP.
The Americans had a drill ship and it went round the world drilling where it could. They'd realised that they couldn't use that ship in shallow waters or in the Arctic where there's lots of ice. Difficult conditions. The ship was too big to get there, it couldn't cope with the ice. So the Europeans came up with the idea of chartering different vessels that could go to those areas and take samples where they couldn't go before.
So the mission-specific platform expeditions were born. The Arctic was the first, and the start of a cross-border collaboration that successfully spans Europe.
We've really brought together experts from across Europe.
We are taking advantage of existing expertise in different places.
So BGS here in Edinburgh provides the contractual work and the drilling expertise.
It's my role to see what is possible technically, what sort of water depths are the scientists trying to work in, what is it they're trying to achieve. Then look at all the options, what sort of platforms you can use, what sort of vessels and ships, and all the logistics associated with running that operation.
Our colleagues at Bremen University have the onshore storage for the cores.
Bremen has this magnificent core repository. They have the know-how on how to deal with cores.
It's a big treasure for our university. One of our focus is to work on reconstruction of the climate in the past. You can read in the seafloor like turning pages of a book and therefore know how the temperature, the climate did change in the past. We need to make an effort to predict the climate for the future.
When we drill the holes, we don't just core the sediments, we also lower things down the hole to measure physical properties in the hole. So we've got our partners from Leicester University and Montpellier in the south of France to lead on that one.
The downhole logging is important for several reasons. It's the only measurement that's providing you the actually on the site, in situ measurement of the borehole conditions. You'll be able to match your core to your downhole logs, so it'll place that whole succession in a context.
A fantastic opportunity to work with other scientists, some of who are really at the top of their field.
There's knowledge exchange in terms of the science and there's knowledge exchange in terms of the technology, and you can't put a price on that really.
Geoscience without frontiers. It's one of ECORD's major strengths.
I think Europe has a very strong scientific impact on the programme.
If you look at the scientific contributions and the achievements that we've done, I think we more than hold our own.